Bill, Horizon examines the latest embryo research to find out what doctors and scientists are seeking to achieve and why.
Especially those of you who've come so far.
Last Christmas, King's College Hospital held a very special party to celebrate the birth of its first 300 test tube babies, with the forthcoming debate in everybody's minds.
Secondly, embryo research is in the news at the moment, and Ginny will be talking to you in a moment about the Human Embryology Bill going through Parliament.
For grateful parents, it was a chance to campaign as well as celebrate. Among the guests were MPs who'll be voting in the debate.
Well, Bourne recommended that there should be specialist centres, regional centres all around the country, so everyone has equal access.
Doctors and scientists defend their right to do research on human embryos. They fear the bill could go against them because their work is misunderstood. In that case, they say, patients could be the losers.
Basically, if the MPs tell scientists and doctors to go away, we'll go away. There's plenty for us to do. I can do lots of other things. The real losers will not be us. They'll be the couples who are infertile, the couples who are at risk of having severely deformed children, who they then have to watch suffer and die. And they don't have a loud voice. So in a sense, we're carrying the flag for them.
The bill does not seek to ban in vitro fertilisation, now accepted practice around the world. But it could ban the kind of research that made it possible, begun over 20 years ago by Robert Edwards.
There was so much to learn at that time. We had to learn how the fertility drugs affect the ovary and affect ovulation. And this gave us the opportunity to do research on chromosomes, on early aspects of fertilisation, how to handle embryos, the culture media they would do. And all this was laid down before we even went to a patient. So we had to do a lot of preliminary work.
13 years' research led to the birth of Louise Brown, hailed at the time as a miracle. Her birth spawned an industry, symbolised by Bourne Hall, the most famous IVF clinic in the world, set up by Edwards and Patrick Steptoe. At around £2,000 a go, it represents the top end of a market which many find distasteful. But with 1 in 6 couples infertile, more and more are turning to IVF as a last resort. And with NHS facilities limited, most pay. Many customers come from abroad, drawn by the legend of Louise Brown.
Well, I was living here in England in '78 when I heard the first baby was born. And then, of course, I had the operation trying to open my tubes, and it didn't succeed. So we thought, well, this might give us a chance to have a baby of our own, you know.
This is how IVF is done. Eggs collected from the mother are mixed with sperm, in vitro, literally in a glass dish. And it's the very idea of life begun in the laboratory that has led to public hostility. Yet Edwards himself tried to open up public debate over 20 years ago.
The ethics of this field have bothered us, bothered me even before I met Patrick Steptoe. And I think between 1965 and 1980, that for every scientific paper we published an ethical paper. And we used all the channels of communication that were open to us as scientists. We used our own journals, such as Nature. We had major articles in Nature calling for government action, calling for a licensing authority in 1971.
The long-awaited bill soon comes before the House of Commons. It would make certain practices, like cloning, illegal. But MPs will have a free vote on 2 alternative clauses: to permit research on human embryos up to 14 days, or to ban it altogether. Till IVF, no one could picture those 14 days. In normal pregnancy, they begin in the fallopian tube, when sperm meets egg. A single sperm penetrates the egg's outer shell, and 2 shadowy blobs appear, called the pronuclei, the packets of chromosomes from sperm and egg. Over the next few days, the egg cleaves as it journeys down the fallopian tube. At this stage, any one cell in the pre-embryo could become anything, placenta or baby, and it could still divide into twins. At about day 5, it enters the womb, still no bigger than a pinprick. It begins to pump in fluid and blows up into a hollow ball of cells, a blastocyst. Fewer than 1% of those cells will become the baby. The rest will form the placenta and support systems. Around day 7, the embryo bursts out of its shell and hatches. Only then does it begin to implant. It burrows into its mother's womb, which takes about a week. Then an extraordinary event occurs. A ridge appears called the primitive streak, the start of the spinal cord and the embryo proper. Now the embryo is truly individual. It can no longer twin. It's at this stage that the bill would prohibit research. But opponents believe that even the earliest pre-embryo has a soul. They believe that life begins when sperm meets egg, a view not everyone accepts.
I'm no theologian myself, but a lot of theologians argue about this question, and there's a well-documented view that the soul, for example, cannot enter in before the primitive streak stage, because twinning can still occur, and when you have identical twins, clearly each of those individuals, as we may now call them, has its own separate soul.
I don't think there's any moment when human life begins. I think we're looking at a continuum. The egg and the sperm are alive. They are human, but they're not human babies. The embryo is a stage further on, but I don't think that's a human baby either. The fetus is obviously becoming a baby. It then starts to have form, but we're looking before pregnancy has established, before pregnancy has even started.
But with IVF now standard practice, why do research at all? Most is designed to improve results, and techniques of egg collection have advanced. A vaginal probe provides the surgeon with an ultrasound picture of the ovaries. With a fine needle, he flushes out the tiny sacs in which eggs are stored.
There's a follicle appearing on the screen there, and that brighter echo there, which I'm jiggling, is the tip of my needle. So we just pop quickly into the follicle like that, and aspirate. Clear follicular fluid. Flush, please.
Using ultrasound, the procedure can be done without surgery. A general anaesthetic is optional.
Do a needle wash and send that off, please. Okay, we'll see if there's an egg in there. Thank you. Flush when you're ready.
Hormone treatment has also improved. It's given so the woman superovulates. Instead of the usual 1 egg per cycle, up to 20 or more can be harvested.
In that pot.
The new drugs produce riper eggs, but they add to costs, and though clinics vary, on average, only 1 couple in 10 will take home a baby after IVF. The eggs are mixed with her partner's sperm, and 24 hours later they're checked to see if they've fertilised. The surface of the egg is cleared, so the embryologist can look deep inside for the sign of successful fertilisation, the 2 pronuclei. When the embryos are 2 days old, As many as 3 will be replaced in the mother, in the hope that 1 will implant. This puts her at risk of twins or triplets, but more often than not, it doesn't work. Patients return again and again for treatment. This woman was on her 4th attempt.
The next 2 weeks will be hard, because you don't know, and you don't really feel anything either. You don't feel whether you're pregnant or not. But I'll go back to work, and hopefully I'll keep my mind off it.
At Bourne Hall and some other clinics, surplus embryos are frozen so that unsuccessful patients can return for another try at reduced cost. But though techniques are improving, frozen embryos are less successful, so many patients will never be lucky. Alternatively, spare embryos may be used for research. It's the patient's choice.
I think they should be allowed to do researching, otherwise, well, they're not going to make any progress if they're not allowed to. So I don't mind them doing any research on my embryos anyway.
A medical or clinical procedure that only has a 10% success rate cries out for research. Indeed, I would say it's irresponsible to be practicing such a procedure without a firm backing in research.
And here in Edinburgh in 1982, the MRC first began to support embryo research to find ways of improving the success rate. They funded a project to tackle the key question of IVF. Why do so many embryos fail to implant? The suspicion was that they might be genetically abnormal. Using donated eggs, they developed embryos to the 2-cell stage. Used to working with blood samples containing millions of cells, Dr Ros Angel had to examine the chromosome content of just 2. At fertilisation, a normal embryo acquires 2 sets of chromosomes, 23 from mother, 23 from father. So this is what Dr. Angel would expect to see. It's a normal embryo with a total of 46 chromosomes. But in some, she found errors. This embryo had only 45. It's missing a number 15. Others had extra chromosomes, for example, an extra 21. This would be a Down syndrome baby. And this embryo had a whole extra set.
In summary, what we found out was that about a third of the embryos that are fertilized in vitro have got abnormalities in their chromosomes such that they could never go on to form babies. We don't think that these chromosome abnormalities are a result of the IVF procedure. These are the sort of abnormalities which occur naturally in miscarriages, and it's only because we've been able to get access to very early human embryos that it's been possible to identify them.
So IVF research revealed chromosome errors which may occur naturally in the egg, even before it's released from the ovary. Back at this stage, the egg still contains 46, like every cell in the woman's body. Before fertilisation, these must be reduced to 23, the same number as the sperm. And it's during this complex division process that things may go wrong. The chromosome pairs line up inside the cell on a spindle structure, a network of filaments, and are pulled apart. Half remain in the egg's nucleus, the other half are shed. And this is where errors could occur. The filaments stretch and may break. So the egg ends up with an extra or missing chromosome, the kind of error Dr. Angel found. Professor Baird points out that many patients are in their late 30s when such errors are more likely to occur. But how far does this explain the high failure rate of IVF? Cambridge scientists believe there are other factors. They say that chromosome damage may also be caused by the handling of eggs in the clinic. A recent experiment showed that human eggs are surprisingly sensitive to temperature changes. They examined eggs which had been allowed to cool from body to room temperature for 10 minutes or so, as could easily happen in the clinic. They found chromosome changes in 80%.
We thought, well, okay, what happens if we warm those eggs back up to body temperature and incubate them for 4 hours? Do you recover the normal chromosome organization? And when we did this, we were very alarmed to find that you didn't. 75 to 80% of your eggs remained chromosomally abnormal. And if you fertilize those eggs, then you will get chromosomally abnormal embryos. So I actually firmly believe that the levels of chromosomal abnormality that have been found in IVF embryos are due to factors such as this. Very simple factors that can be easily remedied experimentally by changing one's procedures.
Johnson believes research could raise success rates to as much as 70%. This student is practicing a new technique called zona slitting on a mouse egg. The outer shell of an IVF egg is harder than normal, making it more difficult for the embryo to hatch. Dr. Jacques Cohen used a fine needle to slit the shell before replacing the embryo in its mother.
He doubled his pregnancy rate just by that one simple procedure. So there is clear evidence that research, well-directed research, actually will improve therapy.
But does this justify the use of human research material? Edinburgh scientists had to work with living embryos because it's only when a cell divides that you see the chromosomes. To do this research, they created their own by fertilizing donated eggs. They point out that embryos rejected by the clinic might be abnormal anyway, but couldn't some of this research be done with animals?
If you're going to investigate some of the abnormalities, some of these abnormalities only occur in man. We seem to be the only species, for example, that has this high instance of chromosome abnormalities, and it just wouldn't do to only use animal material.
Making embryos in the laboratory is what critics condemn most. How do scientists justify creating life for research?
We all know that cells are alive, the egg and the sperm are alive. What one is doing in the course of in vitro fertilization is joining the sperm and the egg together, allowing them to join, which makes a new genetic constitution. Now, if that fertilized egg is destined to be a wanted baby, to be replaced in the uterus, then to me it's quite wrong that any research is done on it that might lead to a subsequent abnormality. But if it's not to be replaced in the uterus, if there's no uterus for it to be replaced in, then it's got no future, no developmental potential. It can't live more than a few days anyway. So I don't think you are creating life. I think what you're doing is fertilizing an egg.
The collection of material for research raises its own ethical problems. As more patients opt to have embryos frozen, the number of spares for research becomes fewer. An alternative source is eggs from donors, for example, from women about to undergo sterilisation. And there are volunteers. This means they have to take drugs to superovulate, and it's not without risk.
There is a syndrome associated with this called the ovarian hyperstimulation syndrome. And in this case, the ovary can become very large. It can become the size of a rugby ball. It can cause extreme pain, and you can get fluid in the abdomen and even fluid in the chest. Now, all gynecologists working in this field are aware of the syndrome, which can occur to any patient having fertility treatment, and are on the lookout for it. If it occurs as part of fertility treatment, I think it can be understood that it is a natural consequence of, or one of the side effects that one might expect. However, I think it would be difficult justification in giving this high doses of drugs to women who are not having fertility treatment merely for the purpose of getting eggs.
In such an ethical minefield, few would question the need for control. IVF centres such as this one at the John Radcliffe in Oxford are already subject to scrutiny by a licensing authority set up 5 years ago to approve research and to license clinics.
This is simply a storeroom.
It's still voluntary, but will be made statutory by the bill.
Our second scanning facility, so that we when egg retrievals are taking place, we are not limited to no other work being done.
Chairwoman is a former Lady Mayoress of London.
Our role is a dual role, that of monitoring the work that's carried out in the clinics and in the research establishments, and also acting as public watchdog and really interpreting to the public the work that's being carried out, trying to present it to them in words that they can understand.
Tell us about your record keeping and confidentiality thereof. I mean, I've seen notes in a heap in the corner there.
These are the cycles which have been recently completed, and out of hours this room is locked.
What happens behind that?
There are 3 couches here.
Can I ask you,
are there 3? Yes. Each of these, behind each curtain here is a couch, and there have been 3 egg retrievals this morning, so each one has a lady lying there. And we've done
Critics say the board contains too many interested parties.
Nurse's station.
I wouldn't say we're all enthusiasts. I think a number of us have quite strong reservations on particular parts of the work which are expressed, and we have quite heated debates sometimes on the licensing authority. But the whole point of a licensing authority is to make sure that certain guidelines and rules are properly applied. And if you had somebody on the authority who totally disapproved of the whole thing, I think it would be very unhelpful. It would be a bit like having a rabid teetotaler on a licensing authority for pubs, wouldn't it?
Well, there's myself as director of the unit. We have Dr Sargent, who's the senior scientist in the unit. Dr Docras, who's one of our researchers, who's on full-time research as a Rhodes Scholar.
John Radcliffe's scientists are about to be grilled. But first, a question for the clinic's director.
Look at your statistics, which we have, I think, in 7 here. Using the awful Americanism, take-home baby rate. We haven't got that down, which is what the public want to know,
well,
really.
It would be 24%.
24%? Well, that's very high, isn't it?
Yes.
That's very good.
High.
Yes,
Very good indeed.
very good indeed.
Yes.
Is
The
it
average is only about 10%. Am I not right?
a little higher than that? Yes.
10 to 12.
Yes.
Can we go to your research projects now?
What I'm basically developing is a trophectoderm biopsy, which is at the blastocyst stage where I get more number of cells, and then these can be used later for genetic analysis by amplification techniques.
So you're actually growing the donated pre-embryos in vitro to the blastocyst stage?
These are spare embryos that I work on, which I get from the IVF unit.
From a layman's point of view again,
Yes.
what stage of growth would that be? How many days?
This is approximately when I slit to cause a herniation, when I would start working on the blastocyst, approximately day 5 or 6. And then it survives till around day 7 or 8 in vitro. We haven't been able to culture them beyond day 8 at all, so that's the upper limit.
When you recover this material, the cellular material, are you using that to...
This is a review visit by the board to check that scientists are sticking to the rules. In accepting a proposal, they have to be convinced it's of clinical value and that it could not be done by using animals. Have they ever turned a proposal down?
More often what happens is that we send them back for more information. There hasn't been enough information given to enable us to assess it properly, or sometimes we ask for a certain part of it to be modified. But sometimes, for instance, the research involves replacing the pre-embryo in the uterus at a stage of the work where we feel it's still experimental, where there hasn't been sufficient work done to be quite sure that there aren't going to be abnormalities introduced. Oh yes, we have turned down proposals, and quite often we've altered them.
I think the authority is in some, not doubt, but wants some clarification concerning how the patients are going to be selected for this particular procedure.
The next proposal raises ethical concerns. It's work on ways to treat male infertility.
We think it's best that we use patients that have normal gametes. In other words, the sperm is normal and the egg is normal. And this is to establish that the technique is possible in humans in our hands. Afterwards, if the technique is shown to be successful, then I think it would be feasible to move on to the next stage, which would be to perform the technique in men that have problems with the sperm, which is really what the whole method is about. I think that we have to ask patients to donate their eggs to a research protocol, and I don't think there should be any question of any money or any finance being involved in that. This is a university research protocol.
This is something I think the authority will really have to discuss on Wednesday, because we are discussing what is a proper and what is an improper inducement for women to donate their eggs, and this really touches on it.
I think that the licensing authority has worked extremely well so far, even though it has no statutory powers. But one day something is going to happen where we need teeth, and at present we haven't got them. And I think that people in the country in general, the public, would be reassured to think that the licensing authority had statutory powers.
Though IVF practice is just as strictly controlled, results vary widely between clinics. They depend crucially on the skill of the embryologist, who judges which embryos to replace in the mother. A grading process, which to the outsider looks more like art than science.
Okay, so here are 3 embryos that we're going to transfer today. The one at the top is a 4-cell embryo. One of the cells has started to fragment, and it would be a grade 2.5 on our grading system. The one in the middle is very nice. There are 4 cells, they're all still intact, and that would be a 1.5 on our grading system. And the bottom embryo looks as though there was a 5th cell which has started to fragment. Again, it's quite a nice embryo, although the cell fragmentation does take it down to a grade 2. All you can use is your experience and your knowledge at looking at embryos, and sometimes you can't really explain to somebody why you particularly pick one embryo in preference to another. It's just a feel that you get over the years of looking at embryos.
To reduce the element of guesswork, researchers at Hammersmith and York University are collaborating in an unusual experiment to test the potential of an embryo by measuring its appetite. The embryo is incubated in a carefully measured drop of culture medium, and it's this drop which is kept for analysis. The brew consists of glucose and other nutrients, the embryo's diet for the first 2 days of life. Microsamples of the used medium are sealed into tiny capsules and rushed off to York for analysis.
Good morning, passengers. This is York Station. Good morning, passengers. This is York Station.
At York University, Dr. Henry Lees has designed miniaturized equipment so they can measure the appetite of these microdots. Even at 2 days old, they already need food. Fluorescent assays enable them to measure how much of the nutrients the embryo has consumed and how much has been passed out. They hope this will allow them to predict the likely success of eventual pregnancy, as Lees has found it does in mice.
We're hoping this will lead to a test, a biochemical, a quantitative test, which we can put numbers of embryo health. And on the basis of this test, you could select the best 2 or 3 embryos to replace in the uterus. And we hope this would increase the success of that particular part of the procedure, because this is the point at which there's by far the highest failure rate.
Lees and his team believe the method has great potential, though with the looming prospect of the bill, it's hard to plan ahead.
Karen can supply the cocktail.
Because it does not directly involve the embryo, his research may not be affected. But what are the implications for other scientists of a ban on human embryo research?
If you ban it altogether, that actually makes doing anything to embryos that might be construed by a court as being research open directly to criminal prosecution. So it's not that you are disobeying a regulation, it's that you're actually breaking a law by doing anything to an embryo. Now, if you think what that actually means to a clinician or scientist, what happens if you change the culture medium? Is that an experiment? Is it research? Would you be open to prosecution? So you become very conservative. You stop making all the sorts of improvements that will, I'm absolutely convinced, lead to increased therapeutic rates, success rates, and so on. You stop all that. In fact, you'll probably drive a lot of people out of the whole area altogether. So you'll stop IVF in a lot of places.
And some critics would choose to stop IVF. They say resources should not be poured into infertility in an overpopulated world.
Unfortunately, far too little money is poured into research into infertility and the treatment of infertility. The majority of IVF centres in this country are funded either privately or through charity organisations, and there is very little funding from the National Health Service for infertility treatment. At King's, we raise money through charitable events and through fundraising events, and the money is raised by the patients themselves. The patients have formed a support group specifically to support the IVF unit and to keep it running.
Suspicion has been raised about long-term effects on the health of mothers and babies.
There have been rumours, for example, that people have had strokes and heart disease, and that even some women might risk ovarian cancer with the use of fertility drugs. There's really absolutely no foundation for those views. Indeed, after all, fertility drugs have been used since the early 60s, and the incidence of ovarian cancer quite clearly has not increased as a result. But I think people are always ready to scare patients, particularly when they feel that there is something slightly disreputable about the treatment. I think that's one of the problems.
As for the babies, Bourne Hall has celebrated its first 1,000, and with thousands more around the world, doctors claim there's no clear evidence of ill effects. Louise Brown herself is a healthy and bright 11-year-old. But though the strongest campaigners may be IVF parents, it's not just the infertile who stand to gain from embryo research. Ironically, work in the Edinburgh Infertility Unit has led one scientist to develop a new contraceptive.
I spent a year at the World Health Organization, and it became very apparent to me during my time there that in terms of global issues involving human reproduction, the major problems are not really infertility. The major problem at a global level is overpopulation.
Research revealed that 5% of couples can't conceive because one partner makes antibodies to sperm, and that gave Aitken an idea for a contraceptive vaccine. At ejaculation, some 200 million sperm cells enter the woman's body. They're looking for just one cell, the egg. And this is what successful fertilization looks like. The surface of the egg is smothered with sperm. The idea of the vaccine is to prevent the sperm from recognizing it. It works like this. On the surface of the shell surrounding the egg are microscopic markers. These antigens act as guiding beacons to the sperm. The vaccine contains antibodies to the egg, which block these markers. In effect, they mask them, preventing recognition. And here's a treated egg. The sperm are sliding over the surface, but they don't bind. The few you can see on the edge have been trapped under the microscope slide. Test tube trials are underway. But what if there's a ban on using human embryos?
If there were to be a ban on in vitro fertilization and embryo research, then the development of a contraceptive vaccine simply couldn't proceed because we would have no means of assessing whether our vaccines were effective or not. It would be immoral, I believe, to go into clinical trials without a clear idea of whether you have an effective vaccine in your hands.
You'll be TV star. I told him you'll be TV star. And you make me assistant.
Say bye, Brian.
Yeah.
For supporters of embryo research, there's one development they most fear to lose.
Say bye. Bye. Have a nice weekend. See you Monday morning.
Say, give me all news on Monday.
Bye.
It's one which could help families like this at risk of inherited disease.
All right.
Simon suffers from adrenoleukodystrophy, a rare disease of the central nervous system.
You had a good day? Eh?
It's a disease passed on by mothers to sons. It developed unexpectedly when Simon was 8 years old.
It was just silly little things, really, like his coordination. He'd sort of run up the stairs, but he was very unsure coming down the stairs. I got quite a few letters home from school saying that there was something wrong with Simon's eyesight. There. All right? Oh dear.
Truth finally dawned on Lynn during a family outing with her sister Debbie.
What really made me realise there was something wrong, we went to Alton Towers. We took the children there for the day, and we queued up for ages, hadn't we, to go take him on the Black Hole. And he was off with my mum playing and that. And when he come running down, it was just that I could tell there was something wrong with him. I mean, they say it's mother's intuition. I don't know, you know. Right, let's see what you've been doing. Ready? By the Christmas of that year, Simon couldn't walk, he couldn't talk, he couldn't eat properly, he was incontinent. But mentally, he was aware of everything, you know. He's still the same as an 11-year-old, which is what he is now, an 11-year-old boy. Simon, I'm talking to you.
They'd never heard of the disease before and didn't know it was in the family. Lynn's sister Debbie found she also carried the gene for ALD. So if she had sons, they too could be affected.
You're not going to talk to me?
I just thought there's no way that I'm going to be able to have a family, because I couldn't possibly consider bringing a son into the world knowing that he may well suffer the way Simon has suffered. I've seen him suffer. And my only other option that I thought I had was to conceive normally and wait for about 3 months to have a test done on the baby to see which sex it was, and if it was a boy, have the pregnancy terminated, which I didn't want to do. So I thought, you know, this is it. I'm not going to be able to have a family. I was quite shattered about it.
An unexpected option was offered at the Hammersmith Hospital by Robert Winston.
I'd just like to go through your last treatment, because I think it's quite valuable for us to do that at this stage.
Debbie was attending the clinic when she learnt she carried the gene. Last November, she became a first guinea pig in trials of a new procedure to prevent the birth of handicapped children.
You're already doing better.
It's never been tried before. She knows the outcome is uncertain. Debbie is trying to have a baby by IVF. In choosing the embryos for transfer, there will now be an extra criterion. They must be female. But the first step is egg collection, and at first it doesn't go well.
I remember the nurse, or one of them, saying something about no eggs, they hadn't found any eggs. I can't remember how long that had gone on for, but when I heard that, you know, I started to get very anxious then.
There was an egg in the flush, Jacob.
There was one.
Yes, that's egg number 6.
All right. Have a dozen points.
So, the first hurdle is cleared.
How are you feeling now?
A little bit drowsy. Other than that, very happy that we've got so many eggs, 8 eggs, haven't we?
9.
So, 9 eggs, so we're just a bit difficult at the moment, the period of waiting, see how it goes, see if they fertilise. Then we have to wait to see if we have female embryos to put back. So it's a bit difficult now.
3 days later, and it's going well. 6 fertilised embryos, but are any of them girls? The 8-cell embryos have been brought for biopsy, each no wider than a human hair. A single cell is gently removed from each so the DNA can be analysed. Research suggests this should not affect the baby, though as yet there's no living proof.
Ultimately, one has to say that we can't be absolutely sure that we haven't caused damage, but all the available evidence would show that we haven't done. And until babies have been born, we will be in exactly the same situation as the test tube baby treatment itself was 11 years ago. Until Louise Brown was born, there was no guarantee that she would be healthy and normal.
The minute samples are carefully prepared for analysis. It's only possible because of a revolutionary new process. The tiny strands of DNA will be copied over and over again to produce 10 million times as much as in the original cell, enough to test chemically. And now, the moment of truth. Results show up as bands of light on a photographic gel. To the expert eye, the patterns reveal each embryo's sex.
So 2 and 3 and 6 are females.
Results show up more clearly on a Polaroid photo. The thick band at the top reveals the presence of the male chromosomes, so columns 2, 3 and 6 are girls.
What we've done is to look at the 2 best ones, and what we're planning to do is to transfer 2 embryos, all right, which we're as sure as we can be a female. But this is still an experimental technique.
Yes.
And I think ideally we would like to have a slightly better result in terms of the biochemistry. But when all's said and done, I think that we're quite safe to do that, and so does Alan. So that's what we're going to do.
Okay.
This is the point when I drop them on the floor, actually.
The likeliest looking pair of female embryos is now replaced.
Right now, before we go to bed, if you come.
On a previous attempt, her pregnancy lasted only 24 hours, so she's not out of the woods yet. How does she feel so far?
Very pleased that we've got this far, and we managed to get 2 female embryos put back. Now it's the most crucial time, the next 2 weeks, so it's feet up and fingers crossed that it works for us this time.
The next stage of this treatment really is to not only sex, but also to try and probe for the individual gene defect. And we'd use exactly the same kind of basic technique, but that's going to require more research. And indeed, each time it's done, we're going to need spare embryos to do it. And I think with each different gene defect, we're going to need spare embryos. So if the work, if there's a ban on embryo research, then all this work will be curtailed. And I think actually sexing of embryos will have to halt as well, because that's still experimental. But certainly detection of individual gene defects will finish completely. And the treatment of genetic diseases using in vitro fertilization will be stopped, I think, permanently.
This is one community that could be helped if Winston moves on to that next stage. They're at high risk of thalassemia, a severe form of anemia affecting Asian and Mediterranean people. It's one of over 4,000 inherited diseases caused by a single gene defect, and like most of them, it affects both boys and girls, so it couldn't be prevented by sexing embryos. This is what it means to have an affected child. 3-year-old Anna has to have a complete change of blood once a month, plus this daily shot of a drug infused through a pump to avoid iron overload, which could kill her.
Anna, don't move your legs. Quick, Anna. Right. Good girl. Yeah. Yeah, come and sit up then. Do it. Our life is spent at home because Anna's on a pump for 12 hours every night. So there's not really much life for me, Anna or Christopher. It's hard because sometimes I get so run down that I can't even do the pump. And if, you know, and Anna does need the pump because if I don't do the pump, it causes more problems. And problems could end up Anna dying.
For the rest of her life, Anna will have to live like this, on borrowed blood, a 4-pint transfusion every month, and the pump 12 hours a day.
Still, you might feel a tiny little pinch.
Discovery of the gene 15 years ago brought the possibility of prenatal diagnosis and the termination of an affected baby. Now the test has been brought forward from 18 to 8 weeks, avoiding the trauma of later termination. But it hasn't eased the pain for some couples who seem to be unlucky every time. Dr Bernadette Model works with one such community.
We almost thought that early prenatal diagnosis at 8 or 9 weeks would be a solution for that. But in fact, we find it isn't a solution. We have the same problem, that people have to go through this procedure time and again, and terminating unwanted pregnancy is a terribly traumatic procedure. And they ask us, now they've got confidence that medicine can help them, and they ask us, can't you do something better? Can't you think of a way of sorting it out so that we can start a pregnancy without having to think of termination?
That could be achieved by IVF and by screening embryos for thalassemia. To detect a single gene defect is more difficult than sexing embryos, but work on thalassemia and diseases like cystic fibrosis is already underway. But for some, the technique raises the spectre of trying to create the perfect baby.
Well, the fact is it doesn't work like that, even remotely. The way that these things are done in practice is that people who have the problem sit down and discuss the problem with expert genetic counsellors, fundamentally. And it's not us who tells them how to use the technology. They tell us. The decision is theirs. And my whole experience of this has given me great confidence in the common sense of ordinary people. They are not asking us to make a perfect baby. What they want is a healthy child.
There are people who believe that we're on a slippery slope. They think that this is the thin end of a wedge. But the truth is that that's what Parliament is there. Parliament is there to regulate that wedge. One is there to regulate that slippery slope. But you can regulate without abolition, and you can regulate without banning. And I think that that's really what Parliament should do. It should be taking a sensible view, not a rapid judgment.
Soon, MPs will confront these difficult issues. To ban embryo research would create its own ethical problems.
If the procedure is eventually developed in another country by research which in this country was thought unethical and prohibited, then there'll be the interesting question of whether or not it's considered ethical in this country for the procedure to be used. And I don't know what the answer would be to that.
We must come to some very careful control organisation that oversees all our activities. An organisation that we can go to for advice if we wish to do a piece of work, that will sanction pieces of work. An organisation that we must explain exactly what we want to do and why we want to do it, and then they can decide if that work should be done. And this should be under the control of Parliament. Under those circumstances, I hope a compromise can be reached to allow the work to go on, and to go on with the highest level of responsibility.
If you'd like to have a complete copy of the script, you can send a cheque for £1.75 payable to BSS, P.O. Box 7, London W3 6XJ. And please mark the envelope the first 14 days. Well, that programme and the issue of embryo research will be discussed in tomorrow morning's Open Air. Taking part will be the editor of Horizon, Robin Brightwell, Professor Robert Winston, who appeared in the programme, and Dr Michael Yanulovich, representing the Life Organisation. If you'd like to participate in the discussion, then ring 061 814 0424. The lines are now open. And embryo research is also the subject of Family Matters this Wednesday on BBC One. John Humphreys will be meeting families with personal reasons for expressing their different conclusions on this moral dilemma. That's Wednesday, 7:35 on BBC One. The fascination of fur is examined in 40 minutes.
You guys come and go.